In this video, we're going to learn how to name ionic compounds that contain polyatomic ions. So remember that we learned that ionic compounds are compounds that have a metal and non-metal. That would be an ionic compound. And more specifically, it would be a binary ionic compound. Binary meaning that there's two different elements only, one of them being a metal. But there are other types of compounds called ternary ionic compounds, which have more than two different elements in them. So there's one metal, and then there's a polyatomic ion. Remember from grade 10 that a polyatomic ion is a group of atoms that are connected together, that are bonded together, and they have an overall charge. So carbonate, CO3 2 minus, is an ion. It's not a compound. Remember, compounds have to have an overall charge of 0. For example, CO2. CO2 is a compound, two different elements, charge of 0. Whereas this is CO3 2 minus. You can use this ion here to make a compound. For example, you could combine it with some sodium to make this compound here, sodium carbonate. So we're going to learn how to name these compounds, the ionic compounds that have polyatomic ions in them, and we're going to learn how to write formulas for these compounds that have polyatomic ions in them. So this is a table that has a whole bunch of different types of polyatomic ions. There's other tables out there. One table that we'll be using for this course or something similar is the one that I'll show you just now here. So this is a table that you might have access to. It has all the polyatomic ions, their name, their formula, their charge. For example, you'll see a bunch of polyatomic ions made with chlorine. You have chlorate, chlorite, hypochlorite, chlorate. You'll notice that the endings of most polyatomic ions end in ate or ite, whereas the ones that we saw before that weren't polyatomic typically ended in IDE, like nitride. So if you see nitrite, that's a polyatomic ion. If you see nitrate, that's a polyatomic ion as well. But if you heard nitride, that's just N3 minus. That's the ion of the element on the periodic table. There are a few exceptions to that rule. For example, you'll notice that ammonium and hydronium end in uh, IUM and mercury 1 is a polyatomic ion as well. Over here, you can see cyanide ends in IDE. So you do need to pay attention to those polyatomic ions, especially the names, because you don't want to confuse them with just regular elements from the periodic table. So you won't have to memorize every single one of these, but you will need to know how to derive them, how to come up with them, and we'll teach you that in more detail in the grade 11 course that we're going to do soon. But right now, it's just a basic review of how to name these compounds. There's a whole bunch of tricks you can do to memorize polyatomic ions. And really, at the end of the day, it's really just working with them as much as possible and practicing with them that's going to help you to remember what their charges and formulas are. I wouldn't waste my time too much focusing on little tricks like this. Practice actually writing formulas and naming them and writing it out, and it should help you to just take it up while you're practicing naming and formula writing. Again, here's another table that has a variety of polyatomic ions on them. Focus on the fact that most of them end in ite and ate, with some exceptions like there. Also cyanide and IDE over here, hydroxide and IDE. Those are the exceptions there. So how do we name these type of compounds? Well, all you do is you name the metal first, and then you name the polyatomic ion without changing the ending of the polyatomic ion. So you don't change the ending, you just name it as is. So for example, the metal here is potassium, NO3 minus, if you go in your table here, NO3 minus, nitrogen nitrate. NO3 minus is nitrate. So that's the polyatomic ion nitrate. So overall, this is called potassium nitrate. Let's do another example here. You can pause the video and try it yourself. Here we have calcium. And then this here, SO4, if you go in your table, you'll see is sulfate. calcium sulfate. So these are nice and easy to name because you're just naming the metal and then the polyatomic ion. You're not changing the ending of anything in this case. So you should be able to try problems out like this and get the correct answer. So you can pause the video and try it out and see if you're on the right path with what you're doing. So for this one here, I have aluminum, carbonate. For this one here, I have calcium carbonate. Here we have sodium hydroxide. Here we have magnesium hydroxide. Here we have ammonium bromide. Here we have aluminum. Be careful here. This is NO2, not NO3. There's two NO2s in here. NO2 is not nitrate, it's nitrite. Aluminum nitrite. So you have to be careful. Look at the formula within the bracket. Look at the formula within the bracket. So where you have polyatomic ions within a bracket, don't count the subscript as part of the formula. Look at what's inside. It's what's inside that counts. So here, here we have ammonium. This is SO3 over here. This is not SO4. It's not SO4. SO3 is sulfite. So you have to be careful when you're looking at your list. This is ammonium sulfite. Here we have ammonium. And then SO4 is sulfate. And then we have Mg, and here we have CH3COO. Let's go take a look at how that's written down in your list of polyatomic ions. So we have CH3COO minus, that's acetate. You can also write it this way here. You'll notice it's written in two ways. You can combine the C's and the O's together and write it this way. It's the same thing though. Acetate this way or that way means the same thing. Just be aware that they can be represented differently when you're writing them out. So this here is magnesium. Magnesium acetate. You will have to sometimes name ionic compounds with polyatomic ions that also contain multivalent elements. The same rules apply. It's just that you have to make sure that you're writing down the number for the multivalent metal that you're dealing with, the Roman numeral. Is it copper 1 or copper 2, for example? So here we want to name this compound Cu2CO3. So generally I start off by writing out the name as copper something carbonate. We have to figure out which copper that is. I'm going to show you how to do that because it can be a bit trickier with polyatomic ions. So you can still do the reverse crisscross, Cu2, CO3. The thing is, you do not want to disturb this polyatomic ion. What you want to do is you want to make sure when you're doing a reverse crisscross, you put a bracket around your polyatomic ion, and this means there's actually just one of that polyatomic ion there. And what you can do is you can just bring the 2 up there and the 1 over here, and you get Cu1 plus, CO3 2 minus. Does this make sense? If you look in your table, you'll see carbonate is 2 minus, so this is copper 1. So we have copper 1 is our metal, and then carbonate is our polyatomic ion. So we have copper 1 carbonate. You could have also done this another way. There's another technique you can use. We replace the polyatomic ion by X. So Cu2X, so that you don't accidentally move that 3. If you move that 3, now you no longer have carbonate. So you replace the whole polyatomic ion by X, put a 1 there, and then you do your reverse crisscross, and you get Cu1 plus, X2 minus, and this really stands for CO3. But the point is we found copper. You could have also done your charge balancing. There's two coppers, and there's one carbonate. This is 2 minus. These you don't have to be positive because they're metals. If you said 2 and 2, that would not have been 0 overall. So this must have been 1 and 1 to get 2 plus, 2 minus, 0. So remember, do not modify that polyatomic ion when you're doing the reverse crisscross, otherwise you ruin the formula and you no longer have the same compound. So we can go about trying to name this one here, CuCO3. So again, this is going to be a copper something. I know it's a multivalent element. CO3 is carbonate based on my polyatomic ion table. I have to figure out what that copper is, so I'm going to do my reverse crisscross. I'll put Cu1. I'm going to put the CO3 in brackets there, and there's a 1 there. Or you could have replaced it by X. Reverse crisscross, and you get Cu 1 plus, CO3 1 minus. Be careful, carbonate is usually 2 minus. So this was reduced. If it was 2 minus and now it's 1 minus, it was divided by 2, so we have to multiply the whole thing by 2. And so that's 2 plus here, and that's 2 minus. So this is copper 2, as opposed to copper 1 carbonate. So you should be able to name these. So pause the video, try it out yourself, and then come and see if you have the same answers as me. So this first one here is copper 1 carbonate. This one is copper 2 carbonate. We've already seen this example. NaOH, sodium hydroxide. So don't get confused here. You don't need to put brackets for the sodium. Why? Well, it's monovalent. It's not multivalent. There's only one type of sodium. It's just sodium 1, but you don't have to do that because there's only one type, so there's no point in identifying it. This, we'd have iron 3 hydroxide. Here we have iron 2 hydroxide. Here we have manganese 2. Be careful here, this is NO2, not NO3, so it's nitrite. Here we have iron, I need to write that as a word, not a symbol. Iron 2 sulfite. This is sulfite, not sulfate. And now we have an acetate here, so we have iron 3 acetate. So remember to do your reverse crisscross or your charge balancing in order to figure out the charge of the multivalent element that you're dealing with. Make sure not to disturb the multivalent element. So for example, if I had, or not to disturb the polyatomic ion. If I had Mn, this NO2 here, 2, and I want to do the reverse crisscross. If you really are scared and you think you're going to bother the NO2, what you can do is, again, replace it by an X. So Mn X2, just do your crisscross, Mn 2 plus, X1 minus. Remember this stood for NO2. Is NO2 1 minus? If you look in your table, NO2 is 1 minus, so we're good. It wasn't reduced, so that makes it manganese 2 plus. So we did the right thing. You should be able to make a formula from a name, and it's the same way that it works normally. You just do your crisscross and reduce if you need to. So we'll do an example here. We'll write the charges of the ions here side by side. So metal first, and then I usually put the polyatomic ion in bracket. Nitrate is NO3, and it's charged outside, 1 minus. Then I crisscross. Make sure that the charge remains outside the bracket. And I get Al 1 NO3 3. Do not change the polyatomic ion on the inside. It doesn't count in the reduction. Polyatomic ion there has to stay the same. You cannot reduce any part of the polyatomic ion. You can reduce parts on the outside, like the subscripts on the outside of the brackets, but that's it. Right now we can't do that though because it's already as reduced as possible. So we can clean up by just taking away the 1, and we get NO3, 3. You could have done this using charge balancing. So Al3 plus, nitrate is -1. Right now that's 3 plus. To get 0, you need 3 of those -1 charges. And so what this means is we have 1 aluminum and we have 3 nitrates. So let's try this one here. We have a multivalent metal this time. So again, we'll write the symbols of the ions side by side. So Cu2 plus, put in brackets the polyatomic ion, put its charge on the outside, crisscross, make sure charges remain on the outside there. We get Cu1 OH 2. We can clean this up by removing the 1, and we get CuOH 2. And again, you could have done the charge balancing method as well. But this is copper 2 hydroxide. Do not confuse hydroxide with hydride. Hydride is for hydrogen. So for example, if we want a copper 2 hydride, we would have CuH2. This is copper 2 hydride. Okay? Hydroxide, that is OH minus. Hydride is for hydrogen if it's an anion. So let's try a few more examples. Let's do the formula for sodium carbonate. So you can pause the video and try it yourself. Here we have Na, not 2 plus, Na plus, 1 plus, sorry. And then CO3, 2 minus, put that in brackets. Crisscross, and you get Na2, CO3, 1. You don't need the 1 anymore, so you just write Na2, CO3. Then we can try iron 3 nitrate. So here we have Fe3 plus, brackets, NO3, 1 minus, do your crisscross, and we get Fe1, NO3, 3, and then you can clean up by simply removing the 1. So what we're going to do now is we're going to do one example where you might have to reduce. So let's do the example of, let's go take a look at our periodic table here. Gallium has a charge of +3. So we're going to do gallium phosphate. Gallium phosphate is Ga3 plus. Phosphate is PO4, 3 minus. Same steps first, crisscross, and you get Ga3, PO4, 3. We need to reduce, only reduce what's on the outside, and so you get GaPO4. So we have gallium phosphate, GaPO4. So let's try a few more examples out. You can pause the video and then come back and take a look, see if you're on the right track. Here we have potassium chlorate. So it's KClO3. This is lithium perchlorate, LiClO4. There's a difference between chlorate and perchlorate. Notice the per, you added an extra oxygen there to your regular chlorate. Aluminum hypochlorite. So let's go take a look at what that looks like in the tables of polyatomic ions. Aluminum hypochlorite is ClO minus. Notice that chlorite is ClO minus, ClO2 minus. Hypochlorite, you just take away one oxygen from there. So there's tricks there to remembering your polyatomic ions. So here we have Al brackets ClO3. Do not confuse this. This is not chlorate. This is hypochlorite. It looks like it's chlorate, ClO3, but ClO3 is actually 1 Cl, 3 oxygens. This is just 1 Cl, 1 oxygen, but there's 3 of them there. It's like saying this, Al 3 plus, ClO minus, ClO minus, and another ClO minus. It's not ClO3. Iron, let's do the ones on the left side first, and we'll come back to these ones after. So calcium nitrate would be CaNO3 2. Calcium carbonate, CaCO3. There's a reduction that had to happen there. Sodium carbonate, we just did that above, Na2CO3. Ammonium sulfate, NH4. In brackets, 2, because sulfate has a charge of -2, SO4. You have to do crisscrossing with the ion there. So be careful. What I would do for that one there, just going to show you the work here, is you're going to have NH4, 1 plus, SO4, 2 minus, crisscross it, and you get NH4, 2, and then SO4 with a 1, but you don't need to write the 1 out there, so you can just drop that. Gallium phosphite would be very similar to gallium phosphate, except you'd have 1 less O, so PO3. Aluminum nitrite, AlNO2 3. Potassium cyanide, KCN. And then if you didn't know what permanganate was, you could take a look at your table of polyatomic ions to find permanganate. If it's not given to you in your polyatomic ion table, unless I told you to memorize it, I would provide to you on the test itself. Permanganate is MnO4 minus. So iron to permanganate would be FeMnO4 and then a 2 there because you did the crisscross. And then lastly, hydrogen peroxide. If we look over here, peroxide is O2 with a 2 minus there. O2 with a 2 minus. So if you want to find that formula, we'll teach you how to do peroxides later on in more detail. I know it's a bit messy here, but we have hydrogen is going to act as a metal, so 1 plus. The peroxide is O2, 2 minus. Crisscross it, and you get H2O2. And that's hydrogen peroxide. So if you had some trouble with this, do go back and retry it and see if you get the same answers as me. So these are some we already tried: sodium carbonate, iron 3 nitrate, and then these were some more practice problems that we already did on the previous slide. But again, you can retry these to make sure that you understand these concepts and compare to my answers on the previous slide. Now, just to finish off, if we look at this Lewis dot structure, this is a Lewis dot structure for a polyatomic ion. I know it's not a compound because this has a charge overall. Compounds have 0 charge. So which polyatomic ion is it? Well, there's 1 phosphorus, and there's 4 O's, and the charge is 3 minus. So this, from your table, you would know is the phosphate polyatomic ion.